right. Thank you for joining us. Today we'll talk about how Checkr uses gRPC. First, an audience survey. Have you ever worked with an API without documentation? Raise your hand. It should be everyone. It happens all the time. Have you ever worked with an API with inaccurate documentation? Maybe a little less, but sometimes, certainly for internal services, maybe a little more rare for public-facing services. What about an API that returns inconsistent types? Or maybe you don't know what the typing exactly is all the time. Cool. So at Checkr, the number of internal endpoints and services for us has grown over the years. So our monolith today has over 500 endpoints and 20 plus other additional production services in the critical path of our application. And so we started to butt up against this problem of undocumented APIs, unknown APIs, et cetera. What is Checkr? So Checkr is an API-first background check company. We provide modern and compliant background checks for thousands of customers, companies like Uber and Lyft and Grubhub and Instacart. And our API needs to be available, otherwise they can't hire. And so our systems have to be resilient and available. I'm Ben Jacobson. I'm an engineer, and this is Paul. And we're both engineers on the Checkr team. And this talk will cover what is gRPC, trade-offs using it for something like REST, and we'll walk through a detailed example of how to get started. So let's first start with what is RPC. So RPC stands for Remote Procedural Call, and it simply is any time you have one service that wants to call another service and ask for information or ask it to do something. That process is an RPC call. And in this example, we have service A. It says, hey, I want you to do a thing to service B, and service B responds with, okay, here's the thing. And historically, there's been lots of ways to solve this problem. So SOAP is a common way. Has anyone used the SOAP API here? We use SOAP a lot. A lot of our integrations are legacy integrations that use SOAP. This is an example SOAP call. You're basically precisely describing the call that you want to make, how you want to make it, and with what input. There's more modern approaches for things like REST using Swagger. So here's a YAML definition of a endpoint stocks / goog, for example, that will return information in a precisely defined way. But what is gRPC? And gRPC is really just an open source framework from Google to make this whole process easier and available in several languages, maybe not any languages, but a lot of languages, and make it super easy. And so this is what the IDL looks like for gRPC. It's very similar to the SOAP version that we just looked at and the REST version, the Swagger version we just looked at. But basically, this is the IDL, interface definition language, the thing that precisely describes the API that you want to implement. And you can see here we have a stocks API or stocks service that has a get stock price. And you can see the exact request that it takes and the response you'll get back. And so an overview, when I think of RPC, I think of really a bundling of these concepts. So we have an IDL. We have a precise definition of what our service does. We have an implementation. So it's whatever the process is, either human or otherwise, to actually implement that IDL. You have a protocol, which is basically how the two services, when using the implementations, talk to each other. And then for us, which is important, is documentation. How do you help others within your organization understand what's available? And so if we compare these kind of concepts with REST or SOAP, which we are all familiar with, we can see like an IDL for REST could be something like OpenAPI or Swagger. An implementation might be, you could use Swagger CodeGen, or you could hand write a HTTP party class to talk to an endpoint. The protocol that you use is JSON or XML over HTTP, and documentation options might be a Swagger UI, open source product, or some kind of Slate documentation. And for SOAP, it's very simple. So a WSDL. Has anyone actually looked at a WSDL? They're a giant XML documentation that precisely describes the whole SOAP API. But that's really an IDL. It's really just a description. And then you can pass that WSDL to an implementation. For example, Savan, which is a Ruby implementation of SOAP, or Zeep, which is Python, the protocol it's using under the scenes, XML, et cetera. And for gRPC, it's really just the same. It's really just a grouping of technologies that help you implement this stack of concepts. So for gRPC, the IDL is a proto definition. The implementation is actually generated for you. So the code is generated by the gRPC directly, gRPC framework directly. And the protocol it uses behind the scenes is something called protocol buffer over HTTP2 in this case. And then documentation we happen to use is an open source project called proto-c-docgen that helps generate documentation for the rest of our organization. So it's really just a bundling of these concepts. And so gRPC is really an opinionated framework for achieving RPC. And you can think of it kind of convention over configuration, which at a Rails conference maybe we're all fans of. It's just a way to achieve this. And so should you be using gRPC? And the answer is probably not. If your organization is trying to scale and you have several services, it becomes more valuable, but you can get a long way with REST. REST is great. Render JSON stuff, I mean, when I first saw this line of code in a Rails project, like this is an incredibly powerful thing. You can move very quickly with this kind of code. It just doesn't scale to a team. And maybe if you do need more flexibility, you can start to introduce things like a stuff serializer that can help you precisely describe what you want stuff to look like to the client. And this will get you even further. And JSON is readable everywhere. And so if we look at a JSON example, the document on the left, you can intuit what it's trying to describe. Even a non-technical person could maybe intuit what it's trying to describe, versus a protocol buffer, which is the way gRPC communicates, is binary, and it's much harder to see what's going on, and maybe even impossible for a human to directly see what's going on. And so you should probably use REST for as long as possible within your organization. But JSON APIs start to feel a little like searching in the dark as you scale. As you have more services, it becomes harder and harder to understand what's available to you. And so here we have service A, and it wants to know what is available in service B. And REST and JSON don't give you kind of the tools out of the box to achieve this. You kind of have to go out of your way as engineers to make documentation or build it into your pipeline in some way. And things get even harder as one service turns into 3 services, and 3 services turns into several services. And so gRPC is an approach to solve this problem. Here's the IDL that we looked at earlier, the proto file. And you can think of this as like a schema.rb for kind of all of your services within your organization. Schema.rb is a very powerful thing. You can open up any Rails project and see exactly kind of what data is persisted, how things work, generally the connections between things. This is just a way to achieve that across services. And so the way it works is we have our IDL. It goes into an IDL repo. We run gRPC tooling on kind of the whole IDL. That gRPC tooling outputs code in several languages. In this example, we have Python and we have Ruby. And then independent services can import that Python and Ruby code and then use it to implement either a call to the service or a response and giving data back to a caller. And so in this example, we have Python client as service A, and it says, hey, I want to get stock price. And I'm going to send you an explicit stock price request. Service B, a Ruby server, looks up the price and sends back an explicit stock price response. And we can even map these concepts to things we should already be pretty familiar with. An IDL repo, again, you can think of as like almost a create table users or your schema.rb file. It describes kind of your application. gRPC tooling, you can think of as Rails DB migrate. It actually changed the state of something under the hood. DB migrate is a table. gRPC tooling might be code. The Ruby code, you actually have to implement now. So here, for active record, you have to actually create a class that actually implements the thing. But you're given kind of all the tooling necessary through application record. And then when you actually want to use it, you just kind of call save. And in reality, active record is abstractly RPC under the hood. You're making a call to a different service to do something, and you're getting back a response. In this case, true, or maybe a validation exception or something. So our journey to gRPC. You can think of our journey over time as more and more services became available, more and more engineers started working on our product. It becomes hard to juggle all of this together, and so we started to slowly experiment with gRPC, introducing it to some services, and then slowly have introduced it to services over time, more and more services, and especially new services that are spun up today. I wish I could stand up here and tell you that there's some mythical point in time in which I can definitely say you should switch to gRPC. You know, oh, you have 25 engineers. Oh, you have 50 services. In reality, it just doesn't exist. There is no exact right moment for you to consider this technology. In reality, it's a giant gray area. There's pros and cons to both. And in fact, you can build a whole business forever using just REST and JSON. And more specifically, this is kind of where Checkr is in our migration. We still leverage REST in JSON. Swagger is our public API documentation is generated through Swagger, but a lot of our internal services are now adopting this technology. And so now we're going to do a very detailed walkthrough. Paul's going to walk you through a very detailed walkthrough of how to accomplish this.
Thanks, Ben. So like Ben said, I'm going to take you through a detailed walkthrough and kind of show you the workflow we actually use at Checkr every day to implement new gRPC endpoints and services. So let's start out with kind of an example in the Checkr context. So one thing that Checkr has to do every day is be able to understand when two records match to each other based on an identity. One important component of that is being able to understand when two names are matching to the same, or just the same name. And this is such an important piece of our stack that we want to be able to expose that to many different parts of our product and make it very seamless for these different services to interact with. So let's talk about what the first step is. The first step in this case, going back to Ben's examples earlier, is to write the IDL or for this particular name matcher service. So first, you need to define the service and what that service does. So we have name matcher service, and we're going to define a method that it can respond to, in this case, RPC match, and that takes in match request and returns match response. Match request actually uses a custom defined message in order to, as arguments. So you have name A and name B. And that particular, those two fields are using person name, which is a new message type that we've defined. So that takes string fields of first name, middle name, last name. Finally, the service is going to respond with a response with types Boolean for match and a float with a confidence. And when the developers finish writing that definition, the first thing we do is push that up to GitHub, to our mono repo for Checkr IDL, where we host all of our definition files. And then we'll go through the typical workflow where we have a pull request submitted. Someone on the team will review that pull request for the new definition. We'll make any edits we need to make. And then finally, we'll merge that into our master branch on GitHub. At that point, we use webhooks from GitHub to build a Circle CI, or run a Circle CI build. And this runs the auto-generated code from gRPC tooling, and then pushes that bundled code into a new gem version on our private gem server via GemFury. And you could do that for any number of different languages. Additionally, we also trigger a webhook to CodeAmp, which is our internal hosting service, and that will run another build that generates HTML documentation. At that point, anyone on the team can go to idl.checkrhq.net, which is our internal intranet, and start to look at the documentation in HTML form. So this is just a preview of what our name matcher docs are going to look like. Again, you can see it's basically, it's rough, it's exactly mapped to what we just created in our definition file, but now we have a nice readable version that anyone at the company can look at very easily. So how do you actually install or start to use the auto-generated code? Like I said, we have now a private gem in our gem repository that you can start to access. So you simply need to define a new source for the internal repository and say gem install or gem Checkr IDL, and then specify the version that you want to start using. Generally, we always advocate for forward compatibility or backwards compatibility. So you're always safe as a client using an older version of our IDLs. Then you would run bundle install, and you're ready to go. Again, you can do this in any language that supports gRPC. So in this case, maybe you include Checkr IDL in your requirements.txt and run pip install requirements.txt. So let's talk about how you start to serve gRPC requests and what that looks like in Ruby. So a very simple Ruby example looks like this. From the auto-generated code, you now have a service stub that you can start to inherit from. In this case, it's going to be called IDL name matcher service. And this service expects you to define a method that maps to the definition file you just created earlier. So we need to create a method def match that takes match request. Once you have that, you can start to interact with the match request object that you defined in your definition file. And then you're simply expected to return a match response object as the final return statement in your match method. As you can see here, there's nothing exposed around network implementation, and you really just have to focus on what the code's supposed to be doing. So how do you boot this server up? The very simple explanation is that you're going to create a new RPC server instance. You're going to attach to a port locally, and then you just basically specify to the server that you want to handle that particular type of service definition. So in this case, name matcher service. And then you're just going to run that forever. So how do we use that in Rails? This is pretty great, but maybe we want to add some additional features on and really make this ready for production. Well, we've found that there's a great open source gem called Gruff that is maintained by BigCommerce. And this allows you to use a lot of the paradigms of Rails inside of with gRPC. So it's just a small framework that you include in your gem file, and you can start to use some of the paradigms there. So the big paradigm with Gruff is that you will create a controller class that maps to each service, and you can put those in your RPC directory. And then you're just going to define a method that maps to the service definition. So on top of just giving you a very kind of similar framework as what you'd expect with a REST controller, Gruff gives you some nice additional features around tooling, so you can start to look at middleware and logging your requests. You can look for authentication, and you can do a lot of other nice things before the request actually hits your controller here. And then finally, you can just run bundle exec gruff to boot up all of your service definitions. So what does it look like to make a request on your client? Well, the first thing you need to do is create a new client stub that's pointed to the location of your name matcher service that's running. So now we have a client instance, but first we need to build the request. So what does that look like? So I just want to highlight here that you can start to interact with any of your definition objects and start to look at them to understand what format these requests are supposed to take. So in this case, if you were new to using the name matcher service, you can check out person name and see that it takes a first name, a middle name, and a last name, and those should all be strings. And there's some really good error handling that's included here for free. If you try to assign to a field that's not available, you'll actually get a method missing error here, and you should know right away that you're not using that object correctly. And that applies to instantiating new objects directly with arguments as well. One thing we found we've had some trouble with at Checkr in the past is that we'll structure names in different ways. We might use a string or a name in different ways. So we may use a string format in one case, an array in another, and a hash finally as the final representation. And you can see here, we're very clear about what structure we expect, and we'll get an error immediately if we use the wrong schema. So finally, let's create our names here. Like I said earlier, we have to understand context around names all the time. And so raise your hand if you can, if you think that these are the same person, Obi-Wan Kenobi and Ben Kenobi. I think anyone who's seen Star Wars can probably make that connection. But we need to be able to understand as a business all the time whether two names might be associated. So now we have our two names, and let's make a request. This is a little anticlimactic, but it's as simple as calling client.match with two keyword arguments, name A and name B, and we're going to get a response back. That response is going to be, again, a Ruby object, and we can call response.match, and yes, Ben Kenobi and Obi-Wan Kenobi are the same person. And response.confidence is very confident in this case. So one bonus we've been able to have using protobufs in general in using IDL is that it applies to other parts of our service communication beyond the simple client-server model. We use a lot of producer-consumer queues at Checkr, and being able to enforce message types there has been very useful for stabilizing some of our critical paths. So just very quickly, just to show you how this might work, in a simple example, if you wanted to send a name IDL onto a queue so that other consumers could pick that up, you'd simply need to encode that IDL object in Ruby to a binary, so this encoded name, and then publish that to your queue. And then later on, when a consumer, again in any language, it could be Ruby or some other language, can then decode that message, get the expected output from that message, and do work on it. So this gives you a lot of, it really helps you enforce boundaries across your services, no matter what type of architecture you're using. Finally, let's talk a little bit about throwing and handling errors. If you've ever used networking before, you know that there are errors that are going to happen. So first off, gRPC status codes. gRPC does have status codes, and they roughly map to different HTTP status codes. So in this case, you can see the number 0 maps to 200 OK. I'm sorry to say that 418 I'm a teapot is not mapped into the gRPC definition, so you'll have to just do without that one. So let's dive into what it looks like to throw an error on the server. In this case, we want to validate that each name that comes back, or in each request, does have a middle name. And just for this very simple example, we want to raise back to the client that they should include a middle name. So how do you do that? You simply raise a new error, gRPC bad status, with that particular status code, in this case invalid argument, which basically indicates that the client has done something wrong with inputs. And then you can send back a string that says middle name must be present. So then your client can start to work with that. You may be saying this seems a little limiting in terms of what you can send back as far as error messages go. So let's say you want to have something a little bit more structured. You could easily define a hash of errors, similar to active record resource errors. And then you can serialize those to JSON and send that back as the message that's included as part of the gRPC status error. And finally, if you really wanted to take this further and you want to have structure across your entire IDL, you could actually define a common definition of what an error looks like in your IDL, and you could then just encode that as the message that's included back with the error. So on the client side, this is going to look like you're just handling Ruby exceptions. So you can rescue gRPC bad status, and you can see details, which is actually going to be the error message that you've passed back. You'll get a message, which is a string representation of the code, and then you can see the integer code as well that's defined in gRPC. And in the auto-generated code, you get some additional nice-to-haves like subclassed versions of the different errors. So you can rescue for gRPC invalid argument specifically and handle that differently than another type of status error. So just to take a step back, let's share a few takeaways we've had at Checkr over the last year of using gRPC. First off, we just want to reemphasize that REST can take you a long way. We're still using REST all over the place at Checkr, and it's alive and well. Secondly, we see gRPC as an opinionated framework for service communication. And finally, where we've seen gRPC start to influence our development cycle is that we see it starting to force us to think about contract-driven development. So when we start to build new services, we really think about what the service boundaries should look like and what those services should perform and do in their roles in our server stack. To give a quick shout out again to open source, we're using gRPC. Gruff is the framework that we're using inside of Rails to make gRPC easier to use. And then finally, we use Proto-C GenDoc for our documentation internally. Thank you.
So we still have 10 minutes. If you have any questions, we could take it offline or you could ask. It's hard to see people. Okay, questions, yes. Yeah, it's one port per, not necessarily per service, but per, I guess, group of services. So you could run multiple services on one server. It's kind of up to you on how you think that makes sense. And what makes sense for you, right? Yeah.
Just to elaborate there a little bit more, you could handle for multiple, just using the simple Ruby example, you could handle for multiple services that you've defined here, and just have a Ruby server routing to those different service calls.
Yeah, so there's two questions. All of these libraries that are generated now become dependencies, and that is true. So these are now dependencies of every application that wants to kind of make calls to your service. And there's a build step to build the dependencies, so you as a developer can just import it directly. And your second question was, do you have to re-implement kind of a lot of your data model again into these IDLs? And the answer is yes. I guess as you're slowly converting to this, if you choose to do so, you would have to kind of maybe not re-implement, but re-describe at least your data model so that each service that wants to communicate with whatever you're implementing knows exactly what it's going to get in response. Under the hood, you could continue to use active record to save the data or whatever, but you're going to need a gRPC object to represent that data to the other services. Yeah, so the question is, can I imagine a world where maybe active record and IDL are maybe the same object, or share some kind of code? I think that's a really good idea. I don't think I've seen it done in my research, but it's certainly something that's possible to do. And that would at least prevent you from some amount of code duplication on your server when you're implementing the match call or whatever you're implementing. That's a good call out. Yeah, so the question is, do we utilize streaming at all? So we don't today. We didn't really talk about it, but it uses HTTP2 and has bidirectional streaming kind of out of the box. We don't have a use case, at least today, that I've seen where that would be useful. You might have a business that does like real-time messaging or something to a client where it would be useful, but for us in our domain, it hasn't been particularly useful for us. Yeah, so the question is, do we use it only for trusted backends, and do we handle authentication today? So today we do use it for only trusted backends within our VPC. So authentication hasn't become a huge concern yet, but as we do it to things that are maybe closer to the public internet, it's something we might have to start considering. But I can't speak to how we would implement it quite yet because we haven't had that problem. Yeah, so we do have some node services in that case, which are still trusted backends. But that's where it maybe starts to touching the surface of public APIs. So the documentation says it's not, I think. It says that you can swap out different implementations. You could use JSON if you wanted instead of protocol buffers. I don't think anyone at Checkr has experimented with that. There hasn't really been a need. But if you did want to swap out kind of how the protocol is working, I think you have the ability to do that. There are translation layers that you can run on top of your infrastructure, so you can convert. Let's say a call comes in that is JSON, you can convert that call into something that then calls into gRPC. There's a lot of different frameworks that do that. I don't think we have any of those running in production today, but again, it's something that we might start thinking about in the future. Oh, gRPC Web, yeah, so that's the translation. One of the translation layers, I think there's a few, but gRPC Web will convert a JSON request into a gRPC call to your gRPC service, and then convert the response back to JSON, so you can consume it from like a web service. Today we don't do that. All of our public calls are through JSON APIs that you would normally just build with a Rails app. Again, it's something that we would consider in the future. Today our focus has been on internal communication within services. So the protocol and stuff like that hasn't mattered as much, but if we ever do want to do it on the web, we would have to start to investigate those solutions.
Thank you.
Yeah, thank you.